Okay, so for our test that we were looking at after we done chapter 7, so our patterns test, I'm just going to go through this test in case anyone had any difficulty with any of the questions. So this whole test was actually taken from the 2018 paper. So the first one says, so the first 3 stages in a pattern of grey and white tiles are shown in the diagram below. So stage 1, stage 2, stage 3. So straight away we're seeing that no matter what stage they are, they have 2 white tiles. And then depending on what stage they are, this square seems to get 1 stage bigger each time. So for stage 4, stage 1 had a 2 squared in grey. This one was 3 squared tiles. This one was 4 squared tiles, so our next one we want to be 5 squared tiles. Okay, so if you just wrote in 5 squared there, like you didn't have to write these in, but if you wrote 5 squared and didn't do anything else, you were getting 3 out of 5 marks. Okay, so I am looking for my last squares here to have 5 by 5 grey squares, 2, 3, 4, 5. Okay, and then 1 white square at the bottom right and 1 up here. Okay, so it could just be a sketch, but if you didn't shade in these squares here, then you were only getting 3 out of 5 marks. So even just with your pen or whatever, just over these like that, just to show, okay, those ones are shaded and there's 2 white ones there. Okay, so over here, part B was based on the pattern shown, complete the table below. So in stage 1, it has completed the first part for you. It has 4 grey tiles. Then stage 2, it has 9 grey tiles. Then stage 3, it has 16. Okay, and we might start noticing a pattern here if we look at just the ones that we've drawn so far. So we had 4, 9, 16, 25. So these are all our square numbers going up. So 25 was 5 squared. So my next one is going to be 36. So I don't even have to draw that. But if we weren't sure, we could just draw the next stage and then count up how many squares it had. The number of white tiles then never changes. It's always been 2. So my total is always just this number plus the 2. So 9 plus 2, I get 11. 16 plus 2, I get 18. 25 plus 2, so 27. And then 36 plus 2, I get 38. Okay? Now, I know what I should have done here. I'm going to bring that over here so that we can keep this one up. So let me just try and position that again. Okay, perfect. So let's look at the next page then on this. So same question continued on. Says, assuming the pattern continues, the total number of tiles in stage T of n is given by the formula T of n is n squared plus b of n plus b times n plus c, where b and c are elements of natural numbers. Okay, so it just means that b and c are whole numbers. So if we got decimals there, our answer would have been wrong and we should try again. Okay, so it says find the value of b and c. So there were loads of different ways to do this. The main thing, guys, is the over here. Okay, if we look at our differences between each of these number of tiles. Okay, so even if we look at this for stage 1. Okay, the differences between 1 and 2 was plus 5. The differences between 2 and 3 was plus 7. The differences between 3 and 4 was plus 9. The next difference, plus 11. Okay, so this here is a quadratic series. It is not, we cannot use our formulas that we had where we have the T of n is a plus n minus 1 times d, and we cannot use the formula for the sum either. was like n plus 2, n over 2 times, and so on. Okay, we cannot use them, okay, because there is not a constant difference here. So you cannot use them. Okay, so over here, so it says, assuming the pattern continues, the total number of tiles in this is given by this formula. Okay, so we can do this in a few different ways. So my first way I could do it is say, okay, well, I know that, let's say if n is equal to 1. Okay, so let's say n is equal to 1, then t of n, so my amount, my number of tiles, so my total here was 6. Okay, so I could fill in this equation with n is 1 and t of n is 6, and do that again for, let's say, n of 2, and then say t of n then when it was 2 was 11. So t of n will be 11 in this case. Okay, so I could do it this way, so that I say, so 6 is equal to, and I'm just going to fill in this equation here. So 6 is equal to 1 squared plus b times 1 plus c. So I get 6 is equal to 1 plus b plus c. Okay, and then I can move this 1 over to the other side. Okay, so I can move that 1 over to the other side, like that. And I'll get 5 is equal to b plus c. And then I'm going to do the same thing over here. So maybe if you didn't do it this way, you could always pause and try this way now yourself, especially if you didn't get the answer right. Okay, so for this one, so we'll have 11 is equal to, so I'm going to fill it into this equation again. So 2 squared plus b times 2 plus c. Okay, so 11 is going to be equal to 4 plus 2b plus c.
I didn't get that. Could you try again?
Oh my god, she's going to wreck my head. I'll go over and turn that off in a sec. So I'm going to get 7 is equal to 2b plus c. So I have two equations now in b and c. Okay, so I could do simultaneous equations out with them. Okay, so I could do it one way by doing simultaneous equations. So this is still part C here. So simultaneous equations. Okay, so if I wanted to do simultaneous equations with these, so I have 5 is equal to b plus c, and 7 is equal to 2b plus c. So I'm going to multiply this line across by a minus, so that I get minus 5 is equal to minus b minus c, and then I still have my next line unchanged. So 7 is equal to 2b plus c, and then I can add these two lines together so that I actually get 2. Okay, so minus 5 plus 7 gives me 2 equals minus b plus 2b is plus 1b, and then minus c plus c is equal to 0. So I now have that 2 is equal to b. Okay, and then I have one of my numbers, so I can put this back into one of my original equations. So I'll use my original equation, 5 is equal to b plus c, and I now have that b is equal to 2. So I have 5 is equal to 2 plus c, and I'm going to minus the 2 from both sides so that I get c by itself. So minus 2 and minus 2, and then I get 3 is equal to c. Okay, so that's part C done there. Okay, I found b is equal to 2 and c is equal to 3. That was one way I could have done it. Okay, now I am going to do it out a different way as well, because there is two ways of doing it. So whichever way you've seen, I just want there to be a solution for both. Okay, so the other way that I could have done it is came up with my equation myself. So over here, if I started looking at these numbers and this situation here and came up with an equation, what I was noticing is that, so for, let's say n equals 1 over here. So when n was equal to 1 here, I had my grey tiles, so my grey gave me n plus 1 squared, didn't it? So when it was stage 1, it was 2 squared. When it was stage 2, it was 3 squared. When it was stage 3, it was 4 squared. When it was stage 4, it was 5 squared. So my grey tiles are always giving me n plus 1 squared. And then I have the white tiles, which is always equal to 2. So my total over here, so I could have done it by saying my total is equal to n plus 1 squared plus 2. Okay, so if I done it out this way, that's still perfect. So I'd get t of n is equal to. So I'm going to rewrite this out as n plus 1 times n plus 1 so that I remember that it's not just n squared plus 1 squared. Okay, and then plus 2. So I'll get n times n gives me n squared. N times 1 is plus 1n. And then, so that's my first term in this bracket multiplied by my second bracket. And then my second term in my first bracket multiplied by my whole second bracket. So I'll do 1 times n is plus 1n. 1 times 1 is plus 1. And then I'll just carry down that plus 2 then from the end. So when I am getting my equation for t of n here, so I will get n squared, and I'm just going to simplify this as much as possible. So I have 1n plus 1n, so that's plus 2n. And then I have plus 1 plus 2, which is plus 3. So if I relate that to my equation that was given to me up here, okay, in the place of b, we have 2. So b is equal to 2. And in the place of c, we have 3. So c is equal to 3. Okay, so there were our 2 ways of doing it out. Okay, so I'll just write them a little bit neater up here so that we can move on. So b was equal to 2 and c was equal to 3. And then it says, find the number of the stage which has 443 tiles in total. So that means, so this 443 tiles in total means that t of n is equal to 443. Okay, find the number of the stage means that I am finding n. Okay, now this would be difficult except for the fact that we have now found an equation in n. Okay, so all we need to do here is fill in that equation. So when I fill in that equation, so my equation, I'll just carry it down, was t of n is equal to n squared plus 2n plus 3. Okay, so I'm going to fill that in. So t of n we said was 443. So 443 is equal to. And then we're looking for n, so we can't fill that in. So I'm going to have n squared plus 2n plus 3. Okay, so I'm going to have to solve this as I'd solve a quadratic. Well, that's one way of doing it. Okay, so I'm going to solve this as I would solve a quadratic. So I'm going to move my 443 across to the other side. Because remember, when we look at quadratics, I usually have like x squared plus, I'll just make one up, so 5x plus 3 is equal to 0. So we always have them equal to 0 there when we start to factorize them. So I want this to be equal to 0, not equal to 443. So I'll get 0 is equal to n squared plus 2n minus 440. Okay, so it doesn't matter what side the equals 0 is on, so that is the exact same as this, which we might be more familiar with, equals 0. Okay, so I'm going to factorize that the same way I always factorize my quadratics that have a 1 in front of the squared variable. I'm going to start by finding things that multiply to give me this number, and then I'm going to check which ones of them add to give me the coefficient of the variable. So my factor pairs for 440. Okay, so I can list all of them out. I'll just list random ones because I'm not going to list them all because I don't have enough space. But I'd have like 220, 8 and 55, 20 and 22, 10 and 44, and so on. Okay, so once I list all of these, I am looking for the ones that are going to add to give me +2. Okay, now remember when we are multiplying to give myself a minus, that means that, so this minus here, when we multiply to get a minus, that means it needs to be a plus multiplied by a minus to give me a minus, or a minus multiplied by a plus to give me a minus. Okay, so I'm looking for ones that have the opposite signs, I suppose. So I'm going to have a difference of the +2. So I'm going to go with this 20 and 22. Okay, so which one am I going to make minus and which am I going to make plus? Well, it's going to be a -20 and a +22, so that they add to give me a +2. Okay, so once I have those found, I open up my brackets. I put my variable as the first term in both brackets and equal it to 0. And then I just fill in those two numbers that I found. So the -20 and the +22. Okay, so I'm going to solve for n. So I'm going to let the first bracket equal 0. And then I can get that n is equal to 20. Or let the second bracket equal to 0. So n plus 22 is equal to 0. So n is equal to -22. Okay, now I'm going to go back and read my question to check I'm finished. So it says, find the number of the stage which has 443 tiles in total. Okay, we aren't going to go back -20 patterns. You don't, it isn't asking you to imagine to go back. The stage is only continuing on in these positive numbers. So we're going to go with the n is equal to 20. So it's the 20th stage.